Hello, this is the second in our series of short videos describing how to use the LA19-13-04A VNA. This particular video will show you how to do calibration to measure a non-insertable device, and we will be using the calibration technique, sometimes referred to as the unknown through calibration. Here, we have the device that we intend to measure. It is the lower half of this printed circuit board. It is also known as a non-insertable device, as it has connectors of the same sex at both ends. Here, we have a female connector on port 1 and a female connector on port 2. The actual device itself, other than the microstrip line, is a simple 39 ohm resistor connected in series. It is important to remember that in order to use the unknown through calibration, the device that we are going to use to make the through connection must be reciprocal. That means that the forward transmission coefficient, S21, must be equal to the reverse transmission coefficient, S12. So consequently, our 30 ohm resistor will be fine for this application. The first step in the calibration process will be to connect a short circuit to port 1 and an open to port 2. Now, we are going to be using the same calibration kit as we used in the first video, so we can just check to see which kit is loaded, and indeed, it is the 8444 cal kit, so no action is needed. We go over to our calibration menu. We are going to use the same sweep plan as before, so we don't need to make any changes there. But this time, we select non-insertable DUT for our measurement. We then go on to perform our calibration using the various buttons here. So we are going to start with the short open button. We click on that, and we see that the button at the top is asking for a short on port 1 and an open on port 2. So we click on that, and once we connect our standards, we click on the OK button, and the measurement of the standard is done. We then click on the next button, and that asks us to reverse the connections that we have. That is, connect an open on port 1 and a short on port 2. Here we see what we need to connect. There on the left is the open on port 1, and on the right is the short on port 2. So we are ready to go. We click OK, and the measurement is made. We now close that window. We now proceed to make the load measurements. So step 1 is to connect a load on port 1 and a short on port 2. And here we see what we need to do. A load on port 1 and a short on port 2. So we are ready to go. We click OK, and the measurement is made. We go to the next step, and that is asking us to reverse the connections. So we have made the connections. We click OK, and the measurement is done. The final step is to connect the device between the two cables. So here we see what we need to do. We connect our DUT as the unknown through between the ends of the test cables. Okay, we are ready to go. We click OK, and the measurement is done. We can close that window. Finally, we click on the Apply Cal button to apply the calibration. We get a message telling us the computed electrical length of the DUT. This is just for confirmation that the value is as expected. Occasionally, it is possible to get odd values if you use an insufficient number of sweep points and/or your device is electrically very long, but it is rare for that to happen. So we click Yes to confirm that we are happy with that length, and we are ready to go. Click on Start Measurement to begin the measurement sweep, and there is our device response. We can increase the sensitivity here on S11 display. You can see that we have a fairly flat S11 trace of about -11 dB. Our S21 and S12 are off the scales, so we need to reduce the sensitivity. We can do that very easily by dragging the mouse. And you can see we are looking at close to -3 dB insertion loss, fairly flat over the band. There is hardly any ripple, and that is what you expect from 39 ohm series connected chip resistor across this frequency band. So there it is, a very simple procedure that can be very, very useful. Thank you for watching.